Hello students, this is the Digital Knowledge Irshad Academy with a fresh video of flip-flops. We have already learned flip-flops. They are used in up counters, down counters, left shift register, right shift registers. They are also used as a memory storage in computers. Before going to the flip-flops, let us refresh our lecture 25. Is a NOR gate can be represented by two switches in parallel and lamp connected across two switches, battery voltage, current limiting resistors. Let us see that both switches A and B are open. Open condition is nothing but 0. Both switches are open. The current can flow from here, cannot flow through B, open, cannot flow through A, open, and it flows through lamp and the lamp lights. This gives you a logic 1 voltage. Then now when A is open and B is closed, A is open, B is closed, the current now will flow through switch B and will not flow through lamp. Lamp is shorted by this switch and there is no light coming from lamp, therefore it is 0. When switch A is open, switch B is closed, the output is 0, lamp is not glowing. In the third case, when A is closed and B is open, the current will flow through A switch and will not flow through lamp. Lamp will not glow and will give you a output 0. In fourth case, when A is closed and B is closed, the current will flow through A, will flow through B and back, and will not flow through lamp, and therefore the lamp is 0. This is a not truthable. 0 odd 0, complemented 1, 0 plus 1, complemented 0, 1 plus 0, 1, complement 0, 1 plus 1, 1, complement 0. This is the symbol of NOR gate. Output is A odd B complemented. This can be represented by two transistors, A and B. See that there is a 0 voltage. 0 voltage does not mean 0. This means a small level voltage applied. This is logic 0 voltage and this is logic 1 voltage. When both the A and B going to Q1 base, B going to Q2 base, these are the N, P and transistors. The Q1 and Q2, they are not forward biased, therefore they are not conducting. Whatever is VCC, we get here full VCC with respect to ground. Now, when B is, we apply higher voltage, logic 1 voltage at B, it is forward bias, Q2 conducts. This voltage, this point is shorted to ground through Q2 transistor and we do not get any output here. When B, we are applying logic 1 voltage at B base, the VCC is shorted and we get 0 output. In the other case, when logic 1 voltage is applied at base of Q1, this is forward biased and this VCC is shorted through Q1 to ground. We do not get any voltage here, therefore 0. When both we are applying logic 1 voltage, then both transistor base, this is forward bias, this is forward bias. This point, VCC point, is shorted to ground. Shorted to ground we do not get. Now the truth table is by using switches, can be represented by switches in parallel with the lamp, can be represented by two transistors, and this will perform NOR logic function. Now NOR logic gate is used as SR latch. SR latch. What is latch? Latch is a spring loaded lock often connected to the doors, and when you push you get inside and the door will close automatically, but it will not lock. This latch is attached to the doors in the banks, in the companies and in the bungalows. For the first case, the initial R and S are the two inputs. Q and Q bar are the outputs. The output will be always complement of the Q. The initial state is Q is 0. When Q is 0, Q bar will be complemented. Two transistors, you may take the voltage from one collector, it will give you 0. From the other collector, it will give you logic 1 voltage. The first case, when R is 0, S is 0. Now, the output of Q is coupled as an input to NOR gate 1. Output Q bar 1 is connected as input to NOR gate 2. Now let us see the function. 0 at the input mean low logic voltage at the S input. Then this is 0, this is 0 also applied at the input of NOR gate 1. Both inputs 0, 0 mean the output will be 1, Q bar will be 1. This Q bar will be 1. This one going here, 0 plus 1, the output is 0. With this input, when R is 0, S is 0, Q is 0, Q bar is 1, and S 0, R 0, mean it will hold this state. There will be no change. We can write here no change or do nothing. It is called as a do nothing. No, flip-flop is not doing any job. When we apply combination, R is 1, S is 0. No, R applied here as input 1. This one appears at the gate of second NOR gate 1 or 1. The output is 0 with this combination. This 0, odd 0. The output of NOR gate is 1. No, you are applying logic 1 voltage at R1 means to reset the flip-flop. Reset means clear the flip-flop. Therefore, whatever is the output, it is cleared. Q is cleared to 0. And for this combination, it is Q is 0, Q bar is 1, is called reset or clear. Reset or clear state. Why? Because you are asking, applying logic 1 voltage at R, you are asking flip-flop to reset or clear the output at Q. Now the third combination, when R is 0 and S is 1, mean you are asking flip-flop to set to 1 output. It should give you 1 output. Let us now see. This is 1, this is 1, both inputs are 1, 1. The output is the 0. This 0 appears at the input of gate 2. 0 or 0 complement is 1. With the third combination, when S is 1, R is 0, Q is 1, Q bar is 0, mean you are asking latch to set, and this is called set state. The last combination, when both inputs are 1, 1. Point to note here is you are asking flip-flop to reset clear, at the same time you are asking it to set. Therefore, the flip-flop is confused. Let us see this with the help of this. 1, and this is 1, this 1 here. 1 at the input and 1 at the input, 1 or 1 is 1, the output is 0. This is 0 coming here, and 0 or 1, the output is 0. With the 1, set 1 or 1, the output is Q is 0, Q bar is 0. You are asking flip-flop to reset and set. This is, therefore it is called as undetermined or indetermined. Indeterminate or confusing state, confusion. There is a confusion to the flip-flop, or ambiguous. Flip-flop is confused. No, these were the 4 inputs. For the first set, when R is 0, S is 0, flip-flop, whatever is the previous state, it will hold that state. It will not do anything. It's called this as the do nothing or invalid. With R1, the Q should clear. See that this is R1, the Q is 0. You are asking flip-flop to clear or reset. Third case, you are asking flip-flop to remember 1. With S is 1, Q is 1, this is the output is 1, the flip-flop is set. With both inputs 1, 1, you are asking flip-flop to set and reset. Flip-flop is confused. Coming to the summary. Flip-flops are digital electronic circuits used to store data, informations. Flip-flop has 2 states, 0 state and 1 state, also called bistable. Flip-flop can exist in 0 state or in 1 state. The flip-flop is also called as bistable. Why? Because bi means 2 states. When the input signal causes flip-flop to go to 1 state, it remains in 1 state. It has remembered 1. Flip-flop is 1-bit memory or called 1-bit storage cell. Flip-flop is also called latch, binary and toggle. These are the names given to the NOR Latch. Important property of flip-flop is that it can exist in one of the 2 states. When Q is 0, Q bar will be 1, called 0 state. Why? Because Q is 0. The state is always determined at the output of Q. When Q is 1, Q bar is 0, called 0 state. Why? Because Q is 1. And this will be called 1 state. Ability of flip-flop to retain its state is used as storage device in digital computers. It is used in digital computer types. There are two types of flip-flops, simple flip-flop and clocked flip-flop. Simple flip-flop changes state when the input changes. Simple flip-flops are called latches. The SR latch we have read is a simple one. It will change the state with the inputs. Clocked flip-flop changes the state when extra clock pulse applied at the input. Clocked flip-flop will provide the output when the clock pulse is applied. Uses flip-flops are used as data storage element to store a single bit of data. It is a single bit memory. It will store one bit only. Used as frequency divider, shift registers, counters, storage registers. SR NOR latch that we have already explained. SR means set and reset latches. It has two inputs and one output. SR latch is still among the smallest memory devices in use. SR NOR latch activates when S input is 1, called set state. SR NOR latch resets when the input 1 appears on OR, called reset or clear state, or output to off. When both inputs are SR activated, means they are 1-1 simultaneously at the same time, is called invalid or undefined states. The flip-flop is confused and the output is indetermined or ambiguous states. That's all. Thank you very much.